Hi guys, it's Mrs. Rapoza. I'm going to be going through episode 1 of Mark and Virge's AP exam review. This is all non-calculator. It's all multiple choice. There's 10 questions. On this portion of the AP exam, you should be averaging about 2 minutes per question. So some will be quick and some will be longer. Here we go. Number 1. They give us the function secant of 2x, and they're asking us to find the derivative. This is a gold sheet formula. The derivative of secant, think about it, is secant tan. So if it says secant 2x, it's the secant 2x tan 2x. Luckily, no answer choice says that because I'm not done with this problem yet. If this is anything other than just x, you've got to do a chain rule. So I'm going to multiply it by the derivative of 2x, which is 2. And my answer is going to be answer choice D. Okay, question number 2. Now we're doing an antiderivative, and I have a little chart set up already for us because we're going to need it in this problem. I have to think to myself, what is the antiderivative of this thing? And that's a gold sheet formula. The formula from the gold sheet is this is one of the inverse trig functions. It's inverse tan. So this is inverse tan of x. I have a bound, so I put my bracket on the end, and then I'm finding top bound, so inverse tan of 1, minus the bottom bound, so inverse tan of 0. We haven't talked a lot about this year, but whenever you're doing an inverse trig function, your answer to this is going to be an angle. And so what you're really thinking about is the tangent of what angle is equal to 1. So if I come down to my chart and I look at tangent, I want to know the tangent of what angle is equal to 1. And the angle is pi over 4. So this right here would be pi over 4. Minus. Then I move to this next one, inverse tan of 0. Your answer is going to be an angle. The answer to any inverse is an angle. So I come to tangent, I come to 0, and my answer is going to be the angle. The angle is 0. So this is 0. And then the answer to my question is pi over 4 minus 0, which is pi over 4. My answer is D again. Okay, let's keep moving. Number 3 looks like a U substitution problem. And it says using this substitution, and they tell us what U is, they want us to evaluate this integral. And if you glance through your answer choices, we don't have to finish the problem. We just have to get it into terms of U. So first thing I do for U sub is I find du, which is the derivative. The derivative of x squared is 2x plus 2. Remember when we do U sub, we put dx on the end. Okay, so my goal is going to be to rewrite this using only the letter U. So I'm changing my variable. So I've got an integral. Instead of this, I'm going to replace it with U. So instead of this piece, I'm going to write it as U cubed. Then I've got to figure out what am I going to replace x plus 1 and dx with. So if I come back over to here, I don't have x plus 1 and dx, but I want x plus 1. So I need to factor out a 2, or I need to divide out a 2. If I divide both sides by a 2, I have 1/2 du equals, if I divide out a 2, I have x plus 1 dx. And now I can replace x plus 1 dx with 1/2 du. I can put the 1/2 here. I could have also put it in front of the integral and du on the end. So looking at my answer choices, that's honestly not very helpful. Well, I can eliminate 2 of the answer choices, actually. Answer choice A is out of there because it does not have a 1/2 in the front. Answer choice B, out of there because it does not have a 1/2 in the front. Answer choice C and D are both still in the running. The only difference is the bounds. And remember, whenever we do U sub, we need to get new bounds because those old bounds only work for the letter X. So our old lower bound was x equals 1. I need to know when x equals 1, what does u equal? So I come back to here where we have u, and u is x squared plus 2x. U is, in this case, 3. So my lower bound is 3. I'm guessing that my answer is D, but I'm going to keep working. I'm going to go say my old upper bound was the number 4. So U is 4 squared plus 2 times 4. 16 plus 8. U is 24. And again, the answer is D. Okay. Flip the page and let's take a look at number 4. Number 4 is a limit question. This is bringing us back to unit 1. One thing I noticed, though, is it's saying the limit as x approaches infinity. As x approaches infinity, what we can do, if it's a polynomial on the top, is we can figure out the degree of the polynomial. Don't FOIL the whole thing out. If I just FOIL multiply my two highest terms, I get that the numerator is a negative 2x squared plus ... I'm going to get more terms, but I don't care about the rest. The denominator, if I just multiply my two x's together, I get x squared. And then we have to compare the degrees. So if you remember how we did this, we said when x is going to infinity, we compare the degree of the top and the degree of the bottom. And if the degrees are exactly the same, if it's the same degree, as long as x is approaching infinity, which it is, the answer is going to be A over B, which is leading coefficient over leading coefficient. And so your leading coefficient is negative 2 over 1. My answer is negative 2. Okay, number 5. Let g be the function defined by, and they give us a function here for g. What is the value for c, which the instantaneous rate of change is equal to the average rate of change? Okay, so we have to think about what the instantaneous rate of change is. An instantaneous rate of change is just a derivative. An average rate of change is AROC, f of b minus f of a over b minus a. So I need to find when the instantaneous, or IROC, instantaneous rate of change, is equal to AROC, the average rate of change. Instantaneous is the derivative. So the derivative is 3 plus the derivative of 3 ln x is 3 over x equals the average rate of change. We're given an interval to work with, and so it's going to be f of b, or in our case, g of 3 minus g of 1 over 3 minus 1. And I got to keep solving. So I have 3 plus 3 over x equals, over here, let's see what we have. I'm going to take this over to the side just to calculate what g of 3 is. If I find g of 3, I'm just plugging it into this function. And I have 9 plus 3 ln 3. And if I'm trying to find g of 1, it's 3 plus 3 ln 1. And then we have to know on the calculus exam what ln 1 is. ln 1 is just 0. So 3 times 0 is just going to give me 3 plus 0 or 3. So here I have 9 plus 3 ln 3 minus, because remember it was minus g of 1, so minus 3. And then I have to solve this equation. This turns into an algebra equation here. I'm going to choose to multiply all my terms by 2. So if I just take the whole thing and multiply it by 2, I get 6 plus 6 over x equals, up top I have 3 ln 3. And if I combine these two terms, 9 minus 3 is equal to positive 6. Trying to solve, if I subtracted a 6 from both sides, the 6's are gone. I need to solve for x. X is on the bottom. I need it to go to that right side. So I'm going to multiply both sides by x. Sorry, I need the x out of there. So 3 ln 3 times x. And then I'm just going to divide both sides by 3 ln 3 to get x. And so my answer is going to be, oh, I can reduce this. I was looking and I didn't see the answer. I can reduce this. And, oh, I take that back. That's not what that reduces to. Sorry, guys. 6 divided by 3 is 2. My answer is going to be 2 over ln 3, which is answer choice A. We finally got it there. Okay. Number 6, we're given a graph and we're asked to find a limit. Now, normally when we get a graph and where we're trying to find a limit, it's usually pretty simple. We just look and see from the left, from the right. But this one's a little more involved because it says x plus 1. This is just the graph of g. You have to know your transformations. This graph right here, the x plus 1, is going to shift the graph to the left one. So there's a lot of ways to do this problem. But what I would recommend, and I think is the easiest way, is if we just take our graph and we take the whole thing and we shift it to the left one. So this point goes here, here. I'm just shifting everything to the left one, and I'm going to redraw it as this red graph. To the left one, to the left one. And the red graph is now the graph of g of x plus 1. And now I'm trying to just look at my red graph, and I'm trying to find the limit as x approaches 1 from the left. So here's 1. Coming from the left side. Pay attention from the left side. As I come from the left side, as x approaches 1, your limit is going to be your y value. Well, what's the y value right here? And the y value right there is equal to 1. So my answer is going to be 1. Okay, next up. Got a little bit more recent material. It says particle P moves along the x-axis, and we are given the velocity right here. And it says particle P has a position of x, and the acceleration is a. At time is 2, they tell us this. This right here, x of 2 is -1. That's information about the position. It says find x of 0, and then add it to a of 1. All right. You have to know the order these go in. Whoop. Sorry about that. When you have your functions, it's going to go position, velocity, acceleration. And to get from one to the other, you take the deriv, or if you need to go backwards, you take the antideriv. So we need to go both ways because we need to find x of 0. So when we go find x of 0, we need to go backwards. We have the velocity. So when I go backwards, I'm going to say, let's find our position, x of t. It's going to be the antiderivative of your velocity. And then when I take this antiderivative, it's going to become just t cubed plus, this is going to become 3t squared, and I'm going to put plus c on the end. And then I have this initial condition that I can use. They told me that x of 2 is equal to -1. So I'm going to go in here and I'm going to say, okay, what's x of 2? 2 cubed, 3 times 2 squared, plus c. And when I do that, I'm supposed to get -1. So I'm going to solve for c. I have 8 plus 12 plus c equals -1. I have 20 plus c equals -1. I'm getting that c is -21. And so that tells me that my position function, x of t, is equal to t cubed plus 3t minus 21. But really, we need to find x of 0. Okay, so let's find x of 0. Just sub 0 in here. And x of 0 equals -21. Okay, so we've got this piece. Okay, x of 0 was -21. Now we need to find a of 1. So we've got to ask, okay, how can we find a of 1? Well, we have the velocity, and to get from the velocity to the acceleration, we're going to take the derivative. So I'm going to say, okay, what is the acceleration? The acceleration is the derivative of the velocity. Let's find it. The derivative is going to be 6t plus 6. I need to find a of 1. So a of 1 gives me 12. And now I've got a of 1 is 12. And for my answer, I'm supposed to be adding x of 0 plus a of 1. And so I'm supposed to be adding negative 21 plus 12. And when I add that, I get negative 9. So my answer is B. Okay, keep going. Number 8, we've got another limit one. Whenever you have a limit one, I suggest just subbing in. I'm recognizing, though, that if I sub 0 into the bottom, I'm going to get 0 on the bottom, which probably means this is going to be a L'Hopital problem. I'm going to use good notation, even though it's multiple choice, because on an FRQ, we need good notation. Okay, for good notation, I need to write down that I'm taking the limit of just the numerator. So I write it like this. I just recopy the numerator, and then I sub 0 in. So e to the 0, sine of 0, minus 1, and I show that that equals 0. And then I do the same thing on the denominator. I find the limit as t approaches 0 of my denominator. If I sub 0 in, I get 0. So if you show that you get 0 on the numerator, 0 on the bottom, we get to use L'Hopital's rule. L'Hopital's rule says, recopy limit. And then we take the derivative of just the numerator. Well, the derivative of e to the 3t is e to the 3t times 3. The derivative of sine is cosine t. And the derivative of the negative 1 is 0. That's gone. Take the derivative of the denominator, 2t minus 3. And then after we do that, now we can substitute 0 in. So now I have 3e to the 0 plus the cosine of 0 divided by 2 times 0 minus 3. My denominator is negative 3. My numerator, I know that e to the 0 is 1, so 3 plus the cosine of 0. We've got to know what the cosine of 0 is. Think to yourself, where is 0? Right here. The cosine of 0 is the x-coordinate. They go cosine comma sine. So my answer is 4 over negative 3, or negative 4/3. Okay. Number 9, keep in mind these are all non-calculator. Number 9 says find the area, this is our unit, find the area that is bounded by the square root of x and this function right here. All right, square root of x. Guys, we've been graphing this all week. Square root of x starts right here, and it shoots off here to the right. If I wanted to be exact, I could pick points. I could say over 1, up 1. I could say over 4, up 2. I don't know if I'm going to have to be exact yet. We're going to see. Okay, there's my first one. Actually, let me draw it in red here. There it is. And then my second function is, that was the first one. And my second one is going to be this, which is a line. The y-intercept is 4. It's y equals mx plus b. So I'm starting up 4, and my slope is negative 1/2. So I would go down 1 over 2. I would go down 1 over 2. Oh, they're intersecting. And I can see exactly where they intersected. Okay, so it says, find the area bounded by these two graphs, and, I better keep going, and the x-axis. So I need to keep going here. So if this was 6, I need to go down 1 and over 2 more. This is going to cross at 8. Okay. And we're trying to find this area. I'm going to shade it in. This is kind of a tricky one. It's this area right here. Okay. Now, normally when we do area, we integrate top minus bottom. I have an issue, though. Here, the square roots on top of the x-axis, the square roots on top of the x-axis. All of a sudden here it changes. So I need to think of this two separate ways. For this first area right here, this stuff right here, to find my area, I'm going to say my area equals, I'm going to integrate from 0 to 4 of the top function, which is the square root of x, minus the bottom function, which is just 0, dx. That's my first one. That'll tell me this area. Then I come over here and I'm going to add it to whatever this area is. Well, look at this area. This area, I could integrate top minus bottom, but guys, this is just a triangle. This right here, oops, this right here is just a perfect triangle because this was linear. Oh, do I have a normal pen? Okay, sorry, getting used to this iPad. This is just a triangle right here. We know that the area of a triangle is 1/2 base times height. Well, this base is 4 and this height is 2. So that's going to make our life a little bit easier on that part. So over here, when I integrate this, think of x, square root of x as x to the 1/2. So this becomes x to the 3/2 times 2/3. Going from 0 to 4, plus this right here is just the number 4. Okay, let's integrate. When we integrate, we plug in the top term. So 2/3. If I plug 4 in here, I'm going to say the square root of 4 cubed. Minus, if I plug 0 in, I get 0. And I have plus 4. Okay, over here, if I calculate 2/3, I know that the square root of 4 is 2. And 2 cubed is 8. Keep simplifying because none of my answers look like that. I have 16/3 plus 4, which I'm going to think of as 16/3 plus 4 is the same thing as 12/3. And if I add those guys together, I get 28/3. And sure enough, it's B. All right. Last question, number 10 says, the region R is the area bounded by, and again, they give us these two equations that we're supposed to graph, and we better be good at these. It does not say first quadrant. So it might be in the first quadrant, but they don't tell us. Well, they don't tell us that right now. So first up, I'm graphing the x squared. Okay, x squared looks like this. Parabola. Then I'm graphing x cubed, and you have to know what x cubed looks like. X cubed, a cubic function, looks like this. It kind of squiggles up. So x cubed is going to touch right here, and it's going to look like this. This is what x cubed looks like. Okay, so I'm going to need to find the area that is bounded by these two graphs. So I know I got to figure out where these two guys are intersecting. They're going to be intersecting at 1, 1. I know for my x squared graph that it always graphs over there at 1, 1. And then for my x cubed graph, 1 cubed is 1. So it's also intersecting at 1. So my bounds are going to be 0 to 1. It's asking for the area. I don't need a pi. So get rid of answer choice B and answer choice D. I don't need a pi. And it's just going to be top. I take that back. We're not finding the area. We are finding, I apologize, the volume. I do need a pi of the solid generated when R is revolved around the x-axis. We are not eliminating B and D. We're revolving this around the x-axis. So let's draw in our dotted line. Here we go. Dot. If I'm going around the x-axis, this is a dx. So on the end here, I'm putting dx. Then I need to find if this is a disk or if this is a washer. Guys, this is going to be a washer because it's just this little region. And there's a gap between that region and the dotted line. So let me really get this bigger here. All right, my capital R. I start on, not very good at this. Start on the dotted line and go through the highlight. That's the capital R. It's going to be top curve minus bottom curve. And it's capital R squared minus lowercase r squared. My capital R brings me to x squared. So top is x squared, the bottom is 0. My lowercase r, I start on this dotted line and I just go till I hit the highlighted region. It's this tiny piece here, and it's top minus bottom. Well, the top is x cubed, the bottom is the x's. So that's my setup. Let's figure out which one matches this. And looks to me like it's D. Okay. The bottom question is a BC question. We do not have to do that.